Hi, good evening, everyone. I hope my voice is audible and you're able to see the screen. Yes, I welcome you all for the network and network security internship, which you are going to attend for the next 5 days with us. So, this is an internship organized by Prompt Infotech for the students in and outside Tamil Nadu. And as informed in your channel, the classes will happen in Zoom every day, and the link for this class will be shared by 5:55 every day in your networking channel, that is the WhatsApp channel. And also, note we have already informed you that there is this attendance sheet which you have to fill every day during your class so that you get your certificate. So, your attendance is must for the 5 days, and the attendance link will be shared during the session in your Zoom chat box. You have to open that form link and submit your attendance. Do this for all the 5 days so that you'll get your soft copy certificates. And after every session, we are going to give you an assignment or a to do, which you have to do. And to submit that assignment, we'll again share you a form after the class. You can use that Google form to upload the assignment screenshot, whichever is given to you on that particular day. All right. And students who are here or in offline for the class, office will be open till 8. So even after 7, if you wanted to sit here and work on your practicals together, yes, you are allowed to do that. So you can sit here and you can work on your practicals. Trainers will be here to assist you just in case if you need any assistance. All right. So now let's dive into the class topic, the internship topic. So initially, since this is about network and network security, I hope you all know what a network is, right? So a network is nothing but a connection that you establish between devices. Yes. So connection between devices. Why do you establish connection between devices? You do that so that devices communicate with each other, and then you are able to share data, share resource, and everything. Yes. So basically, let's assume you have 10 computers with you. And for these 10 computers, you wanted to create a network. Okay. So in that case, you need certain network devices. You need certain network transmission media, right? So the first thing which you will need is the cables. Yes. So we are not going to see all hardware or any kind of theory topics here. All that I'm going to tell you now is what you see every day, in your day-to-day lives, and what assignments you're going to do. Based on that, I'm going to tell you each and everything. So with the cable part, I hope you all should have been to your computer labs, right? So in your computer labs, for sure, you must have seen your LAN cable. Yes, you should have seen your LAN cable. So LAN cable would be in either green color, I mean, sorry, in a gray color, or it might be in blue color, right? So that particular cable, the exact name of that cable is called twisted pair cable. All right. So a LAN cable looks something like this. Let's say twisted pair cable. So a twisted pair cable looks something like this. This is the twisted pair cable, or the LAN cable which you see in your computer labs, right? So this particular cable, in general, the standard name of this cable is called CAT cable. You have, CAT 3 cable, CAT 4 cable, CAT 5 cable, CAT 6 cable. CAT stands for category. The abbreviation of CAT is category, but the technical name of this particular cable is twisted pair cable. And in this twisted pair cable, if you see, there is this adapter which is connected, right? This adapter is called RJ45. RJ stands for registered jack. Okay, so RJ connector. So this is basically a connector, and similar to this RJ45, there is something called RJ11, which you should have seen in telephone lines, right? So RJ11 connector and RJ45, I'll show you a difference. RJ45 and RJ11 connectors. So RJ45 and RJ11 connector. Okay, just the connector is fine. Okay, see here. This is RJ45, which you see in LAN cables, and this is RJ11, which you see in telephone lines. If you've seen telephones, you have this connector which is plugged in the telephone, right? So that is RJ11. So RJ11 is used in telecommunication, and RJ45 is used in networking. Okay, so two types of connectors, RJ45 and RJ11, and this cable, which I showed you now, this is called the twisted pair cable. Okay, and if you can see this cable, it has pairs of cables inside. See here, now this you call it a four pair cable, right? You have four pairs, which mean you have eight cables here, right? This is actually used in your LAN, which is your actual LAN cable. Now there is this concept called crimping. Okay, now what is crimping? Crimping is where you separate these cables, okay, and you have to place it in a particular color order, okay, and then you will take this RJ45 connector and you will insert these cables inside this connector. Okay, you will insert it inside, and you have to use a tool called crimper. There is this tool called crimper. So you will use that crimper and you will just press it. Just press the connector so that this cable will get attached to it. So that is how you prepare a LAN cable. So that concept of achieving a LAN cable is called crimping. So crimping is where you take this cable, you separate each pair, and then you keep it in a particular color order, and then you insert that RJ45 and you use a crimper tool to crimp it, and there you get your LAN cable, right? So this is something with crimping. All right. So this is with the cable, the LAN cable, which you've normally mostly seen in your labs, computer labs. Now, apart from cables, what other things you need when you need to set up a network? You need devices, right? So talking about devices, what networking devices do we have? What devices do you know? We have devices called hub, we have routers, we have switch, we have servers, we have wireless devices, we have access points. Yes, all these are devices, right? So we'll discuss about these three devices first. So basically, hub. Now, what is a hub? Hub is a networking device. Again, it is an older device. A hub looks something like this. Hub device and networking. A hub looks something like this. So in hub, you have 8 ports, you have 4 ports, and in some hub, you have 16 ports also. So hub has 4 port hub, we have 8 port hub, and we have 16 port hub. What is the meaning? In 4 port hub, you can connect 4 computers. Now, what is the purpose of hub? If you connect devices to hub, it means the devices come together as a network, which means the devices can communicate with each other. It can share data. Data sharing is possible. So it is a basically to create a network, you use this device called hub. So in 4 port hub, you can connect 4 computers. In 8 port hub, you can connect 8 computers. And in a 16 port, you can connect up to 16 computers or any devices. Now, hub has no memory. Okay, basically, hub has no memory, which means you can connect any device to it and you can disconnect any device. The hub will not know anything. So it is not going to know anything. And that is why they say hub has no memory. But hub, again, there were so many drawbacks with hub, but initially to achieve a network, this is the device which was primarily used. And hub was replaced by switch. Okay, switch is an advanced version of hub, you can say. Okay, now switch you can remember switch as an extension box. You all have seen extension box, right? So in extension box you can plug multiple devices. No, similarly in switch also you can plug multiple devices. In switch you have 16 port switch, you have 24 port switch, and you have 48 port switch. So you have up to 48 port switch where you can connect up to 48 devices. And switch has a memory, and that memory is called MAC table, which means the devices which you connect to a switch, let's say you're connecting computers to a switch. What switch will do is switch will collect all the MAC address of those computers and it will store it inside the MAC table. So switch has a memory called MAC table, which will collect all the MAC address of the devices that is connected to a switch. Okay, and how does a switch look like? Let's see Cisco switch. Cisco switch looks something like this. See, so this is I think this is 48 port switch, and then we have 16 port switch, 24 port switch. So this is a switch. Okay, and all these are the ports which is at the back. All right, so this is a switch. And then coming to router. Router, again, it is an advanced networking device. And what is the purpose of having a router in your network? A router enables you to establish communication with another network. So, to establish a communication with another network, you will use a router. Okay, so between networks, this router will act as an end device. All right, and what it will do in order to establish connection between another network, it will help you to find the best path. It will help you to find the best path. Now, what is a best path? What is the difference between a best path and the shortest path? Now, let's say we are here in Coimbatore, and from Coimbatore, let's say you're planning to travel to Chennai. So, to travel to Chennai, let's say you have three options. One is by flight, and then you have another option bus, and then you have another option train. All right. Now, if you travel by flight, let's say it takes around 45 minutes or 1 hour, let's say. And if you are going to travel by bus, let's say it takes 9 hours, and train it takes around 6 hours. Now, among this, which route do you think if you take, you will reach Chennai earlier. You obviously you're going to answer this option, flight option. Now, assume there is some delay with flight, some delay with the layover times. Flight is taking 10 hours. Okay, from Coimbatore to Chennai. What is the next best option? The next best option would be train. So you cannot choose a route based on the time duration, right? So if you think the lesser the time you will travel sooner, no, that is the shortest path. Now, router chooses the best path. What is best path? Best path is a path with less traffic, not with time. Path with less traffic will always be the best path, not the shortest path. Shortest path is always calculated with time. So your router will not calculate the shortest path like that. It is going to calculate the best path, that is the path with less traffic. All right. So how does a Cisco router look like? A Cisco router looks something like this. See, this is a Cisco router with ports in the back side. It has many ports. Now, talking about ports, I keep repeating this term ports. Now, what are these ports? These ports are nothing but the connection points in each device at the back side. See, if you can see here, you have many connecting points, right? These are called ports. And in ports, you have different types of ports. First type is called Ethernet interface. Ports are also, another name for port is interface. In terms of router and switch, you can call ports as interfaces. Okay, and in that you have Ethernet interface, you have fast Ethernet interface, and you have gigabit interface, and then you have serial interface. So you have these interfaces. Now, normally Ethernet interface is found in older devices, in older routers. Most of the routers which you come across will have fast Ethernet and gigabit interface, fast Ethernet and gigabit interface ports, and then it will have serial interface ports. Now, where do you use these interfaces? This symbol denotes router, okay? So now, if you are connecting a router with a different device, if you are connecting a router with a different device, assume this is a switch, okay? If you are connecting a router with a different device, then you have to use fast Ethernet or gigabit interface. Okay, so a router will have fast Ethernet or gigabit interface, And normally that interface or that particular port is used to connect the router with a different device. All right. Now let's say you have two routers, and if you are going to connect two routers, then you are going to use the serial interface from two routers. So these two routers will have serial interfaces, and serial interfaces are used only to connect to similar devices, that is the two routers. So when you connect two routers, you will use serial interface. When you connect router with a different device, you will use fast Ethernet or gigabit, and even switch has many ports, right? So a switch will have multiple ports here, and the port names for these inside switch again, those are called fast Ethernet. If you come across configuring this, it will have fast Ethernet interfaces. Okay, so interface is nothing but the name of the ports which you find behind these devices, switch and router. Okay, so yes, now overall, I've just given you a gist of what the devices are and what ports are, and then what cables are. Now let's get into actual networking. Now, talking about actual networking, the first thing that you have to know about is about IP address. You should know everything about IP address when you talk about networks, right? Now, for your computer, how do you check your IP address? Where do you go find your IP address? So obviously you go to command prompt. Yes. And in command prompt, you have to type this command called ipconfig, right? So you type this command called ipconfig, and here you find your IP address 1.101. This is your IP address, right? Now, how did this IP get assigned to your computer? An IP gets assigned to your computer when you connect to any network. So whenever you connect to any network, the IP gets assigned. If you don't connect to any network, IP will not get assigned. So every day when you come, you turn on your laptop, you go, the first thing that you do is you connect to a Wi-Fi, right? So when you connect to a Wi-Fi, that is when an IP gets assigned to your computer. So an IP is an identity. IP is nothing but it's an identity to your device in a network. So in a network, you identify a device with the help of IP address, right? That is IP. And in that IP, you have two versions. One is IP version 4 and another one is IP version 6. Okay, version 4 and version 6. We'll discuss about IP version 4, the one that is assigned here. This is IP version 4. Okay, so IPv4 address. So we'll discuss about IP version 4. And the IP version 4, first you have to know about the range of this IP. Okay, so the IP range starts from 0 and goes till 255. So IP range starts from 0 and goes till 255, which means it's a four-digit number separated by dots. So it's 0.0.0.0, 0.0.0.1, 0.0.0.2, and it goes till 255.255.255.255. This is the IP range. All right, so IP range starts from 0 and goes till 255. Now take any number from this IP. Okay, 0 to 255. If you take any number, let's assume we take the number 10. What would be the first IP of this particular range? Now 10 is a range. Any number between the 0 to 255 is a range, right? So the first IP of this number would be 10.0.0.0. And the last IP of this range would be 10.255.255.255. So for every number, the first IP will be this and the last IP will be this. Now, if you take 192, first IP will be 192.0.0.0 and the last IP would be 192.255.255.255. This would be the last IP. All right. So for every range, this is the first IP and the last IP. All right. Now this is IP range 0 to 255. Okay. Now what they've done is they've categorized the IP, this particular range into classes, different classes, and that is classes of IP. So in classes of IP, what they did is they categorized IP into five different classes: Class A, Class B, Class C, and then comes Class D and Class E. Okay. Among this, the first three classes, class A, B, and C, these classes of IP are called general purpose IPs, which means the IPs inside these three classes are used on a generic purpose among users, among devices. So if any device or if you create a LAN, if you are going to set up a network, you are going to use IP from these three classes. So these three class IPs, A, B, and C, are general purpose IPs. Then what are DNE? D and E are IPs which are reserved. So you cannot use it for a generic purpose. Those IPs are reserved for research and development and for multicasting, broadcasting. They have reserved these IP addresses. So we are not bothered about class D and E. All we have to look into is A, B, and C because these are the IP classes which we will be using in our further assignments. So for class A, from 0 to 255, they've segregated the IP for class A, and the range of class A is 0 to 127. And for class B, the range is 128 to 191. And for class C, the range is from 192 to 223. So the remaining IP from 224 to 255 is categorized with class D and E, and which are not used for any generic purpose. All right. Now, when talking about class A, so the range of this IP class A starts from 0.0.0.0, 0.0.0.1, 0.0.0.2, and it goes till 127.255.255.255. That is the last IP of that range. Okay. And for class B, it starts from 128.0.0.0, 128.0.0.1, and it goes till 191.255.255.255. And for class C, it's 192.0.0.0, 192.0.0.1, and it goes till 223.255.255.255. Okay, so this is with classes. Now that you know the range of each class, yes, the first thing you should know when you see an IP is to find out the class. Now, let's say I write an IP 192.168.1.10. What is the class of this IP? How do you find that? You have to look into the first number and you have to see under which class this number falls. So 192 falls under which class? It falls under class C. So this IP belongs to class C. 130.6.3.15. This falls under which class? 130 falls under class D, right? And 10.0.0.5 or 2. This belongs to class A. So based on the first number, you have to find out the class of an IP address. Okay, right. So now we have three classes of IP. All right. Now the next question is who will use which class of IP? That is our next question. We have three classes. Okay. Now talking about users, we have different types of users, right? We have a user under a small network. We have user under a larger network. So an MNC company is different from what we use in your home, right? In your home, you have one or two computers with one modem. So that is one network. And in MNC company, there are like 100,000 computers, which again comes under, creates a bigger network, right? So who will use which class of IP? Now, here in our command prompt, we have got IP from class C. How did we get IP from class C? Why did we get IP from class C? So to answer all this, there is this topic called subnet mask. So they introduced this concept called subnet mask, where this subnet mask defines network and host portion for each class. So for each class, the subnet mask defines a network and host portion. So with this, you can conclude which user will get which class of IP. So this subnet mask will help in assigning the IP address to different types of users. Now let's see how the subnet mask is first set for each class. So for class A, the subnet mask is one network portion and three host portion. For class B, the subnet mask is two network portion and two host portion. And for class C, the subnet mask is three network portion and one host portion, where the N denotes network portion and H denotes host portion. Host means nothing but the computers. All right. So this is the subnet mask which is predefined. You cannot change this. All right. So now, as I mentioned, the host H portion denotes the computers, right? Now, among these three classes, right, where do you find host portion more? In class A. In class A, you have three host portions, right? Which means class A can accept more number of computers. You can use class A of IP to assign to more number of computers. In general, where do you find more number of computers? In large MNCs. So large MNCs with the large number of computers will use class A. And in class B, you see there are two hosts, which means next to large MNCs, all these mid-level companies will use class B. And in class C, if you can see, you have only one host. So small companies and home users will get class C of IP. Now, looking into our IP address, since ours is a small network, where in this network only two or three devices are connected, so we have class C IP, which is assigned to us. All right. So that is how IP gets assigned based on the amount of users. Subnet mask will allow you to choose which class of IP should be assigned to that particular count. Okay. Now this subnet mask, now for namesake, for remembering sake, I've just given N and H values, but there is a exact value which you write for subnet mask that is called default subnet mask value. And how do you achieve that? You just have to replace all the N into 255 and all the host into 0. Okay. Now, for class A, the subnet mask will become 255.0.0.0. For class B, the subnet mask will become 255.255.0.0. And for class C, the subnet mask will become 255.255.255.0. This is the default subnet mask value. Now, always remember, whenever you assign an IP to a computer, you have to assign subnet mask value along with it. So whenever you assign an IP to a device, you have to assign subnet mask. IP and subnet mask are always together. You cannot separate them. All right. If you don't give subnet mask and when you only give IP address, there is no meaning to that IP address. So every time you assign an IP to a computer, it is mandatory that you also give the subnet mask, because subnet mask gives value to that IP. Only with that subnet mask, the IP has a meaning. If not, the IP will not have any meaning. All right. So now that you know how to identify a class when you see an IP address, 13.10.11.15. Now, when you see this IP, you know the class, right? It is class A. Now, when you know the class A, you should also know the subnet mask. Now, class A, the subnet mask is one network portion and three host portion. So next time when I ask you, what is the subnet mask for class A? You don't have to struggle yourself to say 255.0.0.0. Don't stress. Just say one network, three host. For class B, the subnet mask is two network, two host. For class C, the subnet mask is three network, three host. You can just say like that. right? So you can use these terms. But for computers, the computers will not understand N and H. It will understand only numbers, right? So when you assign subnet mask, you have to use these values only. Just for remembering, you can use this N and H thing. All right. Okay. Now, okay. Now let me tell you something practical which you can do. Basically, if you have to practice all this hands-on with all these devices which I'm talking about, routers and switches and computers and all that, you will have to be here live so that you can sit and work on real-time switches and real-time routers. Now that most of you are attending online and only few are here in offline, what we will do is we will go with a virtual tool. All right. So there is this tool called Packet Tracer, which you have to download and install. Okay, so this particular tool is called a simulation tool. It is like a virtual tool. This tool will have computer, this tool will have a switch, it will have a router, it will have a server, it will have cables, it will have firewall, it will have wireless devices. It is going to have all that. Okay. So we will use this tool to practice configuring a device, configuring a network device called a router or a switch or a server. So we're going to use this tool. So we will share you a drive link in your channel. And every day, whatever tool we are discussing, the tool will be uploaded in the drive link. So you can open that drive link and you can download whatever tool you want. Open and download whatever you want and you can install it. I will tell you how to install also. Now, a drive link will be shared to your channel and we'll have packet tracer tool given to you. And that we'll have two things. One is, one folder is for 32-bit and another one is for 64-bit. You can use whichever one you have. I mean, if it is 32-bit, you can download 32-bit. If it is 64, then you can download 64-bit. Once you've downloaded the packet tracer tool, just double click on it and click on yes. And then it is going to ask for next, accept agreement, next, 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 and then click on install. It is just going to take 2 minutes of your time and it will install. Okay, nothing much to do with. I already have packet tracer here. Let me close it so that I can open it from first, right? Now packet tracer is installed. Okay, now that you have installed a packet tracer, just go and go to Chrome or I mean, yeah, for you it will launch automatically since you have installed it for the first time. I'll go open my packet tracer here. So when you open packet tracer, you will get a white screen, something like this. Okay. You are going to install version 7. So you'll get a screen like this asking you to log in, but you don't have to do that. Just in the right bottom, you can see there are two options here, user login and guest login. Just click on guest login. So when you click on guest login, it will open the default website. Just close that, ignore, and it is going to run a time. Okay. It is going to run for 15 seconds. So it's running 3, 2, 1. And then it is going to show confirm guest. So click on confirm guest and packet tracer will be open. This is the packet tracer tool. Looks something like this. Right? This is the working area and bottom here you can find all the devices. Okay, so see here you have network devices. When you select network devices at the bottom, you have router, you have switch, you have hubs, you have wireless devices, you have security, and you have WAN. And when you choose router, you have so many models of routers. When you choose switch, you have so many models of switch. And then if you go select any devices, you have computers, laptops, servers, and all these here. Okay, so we'll come back to this. Before that, I'll go explain another topic for you and then we'll come back to this. Okay, now talking about IP address, there are two types of IP address. Okay, there are two types of IP address. One is private IP and another one is public IP. So there are two types of IP. One is private IP and another one is public IP. Now to explain this to you, first let me go with an example. Okay, assume we are here in India. So the currency that we use in India is INR, right? And then let's take US and the currency which they use in US is dollars, US dollars, right? Now let's say we are traveling from India to US and our flight is from Delhi. So now if you have to go from India to US, you cannot take the rupees and you cannot go use it in US, right? So what you will do when you start your travel, you're going to convert the INR which you have to US dollars, and only then you will go. And you will go there, you will spend all the US dollars, and now you're planning to return. So when you plan to return, you cannot bring those US dollars and use it in India, right? So when you come back, you are again going to convert that US dollars into INR, and only then you start using it inside India. Right. Similarly, there is something called private IP and public IP for a particular LAN. Okay. So before that, let me explain you what LAN is. Now, LAN, as you all know, it is local area network, right? So, how do you create a LAN? Now, let's say you have 100 computers. If you have 100 computers, can you set up a LAN? Yes, you can. If you have 1,000 computers, can you set up a LAN? Yes, again, yes, you can. So LAN, definition of LAN is you cannot define LAN by number of computers. Even when there is 100 computers, you can create a LAN. Even if there is 1,000 computers, you can create a LAN. So LAN is not defined based on the number of computers. Again, LAN is not defined based on the area. You can create a LAN inside a 10 by 10 room also, and you can create a LAN inside a 100 by 100 room also. Right? So LAN is not defined by number of devices, or it is not defined by the area. Okay. So this is this is the basic definition of LAN. Why do you go for LAN? You go for LAN, to interconnect devices. You go for LAN to interconnect devices to achieve two things. One is data sharing. You go for LAN to interconnect devices to achieve two things, and another one is resource sharing, data sharing, and resource sharing. Okay, so now coming back to this private IP and public IP. Now, assume we have two LANs, okay? This is one LAN, a router, and then a switch, and then we have two computers. Okay, and again we'll take another LAN, a router, a switch, and two computers. Now these two are different LANs. Okay, this is LAN 1 and this is LAN 2. Two different LANs, and let's assign IP for these computers. For this computer, I'll assign 192.168.1.10. For this computer, I'll assign 192.168.1.11. For this computer, I'll assign 192.168.1.12. And for this computer, I'll assign 192.168.1.13. All right. Now, these two are two different LANs. They are nowhere connected with each other. Okay. Now, first understand what is the private IP and public IP. Any IP that is assigned to your computer is called private IP. So all these IP addresses, they are called private IP. Okay, so for my computer, I have this IP called 1.101. So now this is my private IP. Okay, an IP that is assigned to your computer is called private IP, and the scope of this IP ends inside the LAN. It ends here. Okay, which means the private IP will not go outside of LAN. It is always inside your LAN only. Okay, so private IP is always inside your LAN. It will never go outside. And there is a public IP which is assigned, to all your network. Public IP. Okay, that public IP will always stay out of LAN. It will never come inside. So its scope, the public IP scope will always remain outside only. It will not come inside the LAN. So private IP stays inside the LAN. Public IP stays outside the LAN. Now we know how to find private IP, right? You know how to find this private IP for your computer. You just go to command prompt and you type ipconfig and it is going to show you your private IP. Now, how do you find public IP for your network? To find public IP to your network, you just have to go to Google and type what is my IP. When you type what is my IP, see, Google will show you your public IP address. So this is your public IP. Okay, this is your public IP and this is your private IP. So private IP is always inside your network, inside your LAN, and public IP is always out of your LAN. You will be able to access this private IP. If you want, you can modify this private IP. You can change it from static to dynamic. You can do all that private IP. Okay, that users are allowed to do. But public IP, you can't do anything. Public IP will be taken care by the internet service providers, ISPs. All right, so they will take care of the public IP. You can't do anything. All that you can do is you can just see your public IP by typing what is my IP in Google. That too, only your network's public IP you can see. Other networks' public IP you cannot see. Okay, so this is with public and private IP. Now, talking about whether IP is unique or not, that's a big question now. Yes, whether IP address is unique or not unique. What do you think? Now, talking about the private and public IP. Now, when someone asks you this question, whether IP is unique, you ask them in return if they're talking about private IP or public IP. Okay, you ask them back whether they're asking about private or public IP. Okay, now when it comes to private IP, listen to this clearly. When it comes to private IP, a private IP is unique inside a LAN. Okay, inside a LAN, now let's say this computer's IP is 1.10. If I go to this computer and if I assign 1.10 IP, it will not get assigned. Instead, I'm going to get an error called IP conflict error. So inside a LAN, you cannot assign same IP to two different computers. Okay, so inside a LAN, IP is always unique. But in between LANs, IP can be same. Now, if I go to LAN 2, instead of 1.12, if I give 1.10 here, it is going to accept. Why? Because it is a different LAN. Okay, so when it is a different LAN, IP can be same. So IP should be unique inside a LAN, but between LANs, IP can be same. All right, now I am connected to Pentest 5G. So in this Pentest 5G, only I can have the 1.10 network, I mean IP. No other computer can have 1.10 IP. But if there is another network, let's say we have another prompt training, right? Now, prompt people who are connected in prompt training can have 1.10 IP because that is again a different network, right? So IP is unique inside a LAN, but it can be same between LANs. This is with private IP. With public IP is unique. Now, if this is public IP ABC, if it is assigned to one network, you cannot go assign the same public IP to another network. So public IP is strictly unique, but private IP unique inside a LAN, but it can be same between LANs. Okay, so this is the difference between public and private IP. Okay, now I'll also tell you the last thing for today, that is private IP range. Now, for each class there is a range, right? For class A, class B, and class C. For class A, the range is 0 to 127, and for class B, it's 128 to 191, and for class C, it's 192 to 223, right? Now, for each class, there is private IP and public IP. Private IP and public IP. Private IP and public IP. Now, what are they? Okay, I will tell you the private IP range. Now, since our topic is about private IP range, for class A, the private IP range starts from 10.0.0.0 to 10.255.255.255. For class B, the IP range starts from 172.16.0.0 to 172.31.255.255. And for class C, the IP range starts from 192.168.0.0 to 192.168.255.255. Now, what are these? These are called private IPs. Okay. Now, let's say you are creating LAN, and for the computers, you wanted to assign IP from class A. If you want to assign IP from class A for computers, you are going to use the 10 series. If you're going to assign IP from class B, you're going to use this series, 172.16 series. If you're going to assign IP from class C, you have to use 192.168 series. Okay, these are the IPs which are reserved for private IPs. All right, so this you will use as private IPs. Now, apart from this, what happens to other IPs? Now, here in class A, entire 10 series has gone out for private IP, right? Now from 0 to 9 and from 11 to 127. What are these? These are public IP addresses. These are public IP address. And again, here 128, apart from this range, 172.16 range, the other IP come under public IP. So that is why for our computers, see, we have IPs 192, 168 series. And below, see the subnet mask for our computer. I said for class C, it's 3 network and 1 host, right? So that is the subnet mask which is assigned here. So IP and subnet mask are always together. They always come together. Okay, right. Now we see a short to do, a short practical which we can see. Now we are going to create a LAN without internet. Okay, so we are going to create a LAN without internet. For that, you need switch. You need a device called switch, and to the switch, you're going to connect computers. Okay, you'll take a switch, you'll connect computers to it using cables. Okay, and for each switch, for each computer, you're going to assign IP and subnet mask, so that it becomes LAN, and this is called LAN without internet. A LAN without internet. This is the first thing which you will do and see in your packet tracer. Now, how do you achieve this? You can go to packet tracer, and in packet tracer at the bottom you see switches. So you select switch, and from the different models you can choose the first one. Just click once and bring it here and click once. So you will place a switch. Okay, or you can also drag and drop. Okay, we need only one switch, so let's delete this. Right, and then we need computers. So go to end devices, and in end devices you have generic, which is the computer. So I'll place 2 computers here. All right, so we have a switch and 2 computers. Now, the next thing is you have to connect this computer to this switch and this computer to this switch. For that, you need cable. This icon here, this orange icon, this is the cable section. And if you click on it, you have various cables. The third cable which you see here is called the copper straight through. So you have to use copper straight through cable to connect. So I select this cable, and what you will do is you will go click on this computer and choose fast Ethernet. And then you will drag this and go to switch, and see this switch is a 24 port switch. So you can connect in any port. So I'll connect in the first port. Again, go choose this cable, click on this computer, choose fast Ethernet, and then go to switch, and see one gone. First port is gone since it is occupied. So we'll connect with the second port. Now that we've connected, the next step is you have to assign IP to this computer, right? So for that, first let's go click on this first computer. Okay, now I'm inside this first computer. Go to desktop and see you have this section called IP configuration. You can go inside this and let's give an IP 192.168.1.10. And when I told you, whenever you assign an IP, you have to assign subnet mask. Now see here, I just go keep my mouse pointer here in the subnet mask and it automatically gets filled. So you don't have to type it, it automatically fills for you. All right, and then go back, go open the second computer, and for the second computer, you're going to choose desktop, go for the IP configuration part and assign IP 192.168.1.11 and the subnet mask. Right now, for my purpose, I'll also note down this IP address so that we don't forget it. Always use place notes, it will help you. 168.1.11. Okay, so this is the IP of this computer and this is the IP of this computer. I use this option, place note, to type this. All right. Now, this is LAN without internet. Okay, so all that I did is in packet tracer, take a switch and take two computers, use copper straight through cable to connect computers with the switch, open each computer and assign IP address and subnet mask. Now you have LAN without internet. Now, how do you verify? You have to verify whether you have established the connection or not. So for that, you are going to use a command called ping command. Okay, ping command, and you will use it in the command prompt. You use it in the command prompt. Okay, now ping is a command which helps you check whether you can establish the connection. You can ping is the command which will help you check whether you're able to establish connection with the destination. All right. So the format of this ping command is you can write ping followed by the destination's IP address, or you can type ping and you can give the domain name also. So now we have only IP. So what I will do is I will go to this computer and go click on this computer. Okay, now I'm inside this first computer. All right. I've selected this first computer. And from this computer, I'm going to open command prompt and I'm going to type the destination computer's IP using the ping command. So I'll type ping space 192.168.1.11. That's my second computer's IP. And when I hit enter, I start getting reply. So this means that the connection is established. So this is a perfect LAN without internet where two devices are connected. Okay, now this is something which you can just replicate. You can just do it in your packet tracer and see. This is not going to be your assignment. I am going to give you one assignment for today. Okay, now this assignment, once done, you have to take a screenshot and a Google form will be shared in your channel. Google form will be shared in your channel. You have to upload it there. Okay. Now, what is this assignment? This assignment is, let's delete this. So you are going to take a Wi-Fi device from here. You have multiple devices down here. Okay. So from this, you have to take a wireless device. Okay, where is this wireless device? All right, and in wireless device, you have this port one. This is like a wireless router. Okay, and you're going to take computers, three computers. That's it. You're not going to use any cables. Whatever should be on the screen, it is on the screen. Okay. So you're going to take a wireless router. You have three computers. Now, for these three computers, you have to connect Wi-Fi from this wireless router. Okay. Take a wireless router and three computers. Okay. Configure the wireless router setting. Create a Wi-Fi. So you're going to create a Wi-Fi in this wireless router and open the computers, connect to Wi-Fi. Connect to the Wi-Fi that is created. Okay. So end of this to do, the output is going to look something like this. You have that wireless router device. Okay, this is, let's assume this is your modem, which is on the screen, and then you have three computers, right? So first thing, you will configure Wi-Fi in this modem. It's just a three setting which you have to change. All right. And then from computer, you have to connect to this Wi-Fi. Again, that is very simple, two or three steps which you have to do. Once the Wi-Fi is connected, the setup which is on the screen, it will change to something like this. It will look something like this. Once you connect to Wi-Fi, it is going to look something like this. You don't have to use any cable for this. If it is connected, it is going to show you like this. This is going to be your output. Okay. Once you see this on screen, if you try pulling from one computer to another, it is going to ping also. From one computer to another, you can try ping and see, and it is still going to get replies. That is okay. But this is your output. What you have to do is you have to take a screenshot of this output. So after connecting to Wi-Fi, you will find that cable kind of thing here, that connection symbol here, and you will take a screenshot of the screen, and we will share you the Google form, and you have to upload that in the Google form. That will be your first assignment for today. Okay, so this is your first assignment. Now the drive link is shared to your channel. So from there you can download Packet Tracer tool. You can install it and you can start working. And the Google Form link will be shared. You can after done you can upload the screenshot to your form. And I hope you all have submitted your attendance sheet, which was sent in the Zoom chat box. So every day, make sure you're submitting that attendance sheet so that you can, you get your soft copy certificate. And yes, the class video, now that it is recorded, once it is converted, we upload this video in our YouTube channel. So you can also watch the class if you want. Once again, you can watch it in the YouTube channel. Yes, I hope you don't have any doubts for today. Let's meet in tomorrow's session then. Thank you, guys.